Part 6, Recognizing the Difference. Chapter 9, How to Tell the Difference. This book has spent 8 chapters arguing, deliberately and at length, that minority scientific positions deserve a fair hearing, that consensus is not the same thing as truth, and that ideas as different as the electric sun, the liquid metallic hydrogen sun, and plasma cosmology have earned real, careful engagement rather than reflexive dismissal. I've tried to model what that engagement looks like, crediting real evidence and real credentials where they exist, naming specific objections plainly, and reporting honestly when a claim failed its own test, as the electric comet model's water ice prediction did in Chapter 6. Picture the reader I have been writing for all along. It is late. A video autoplays. A calm, fluent voice over footage of a churning solar surface tells you that something is coming, that the people in charge either don't understand it or won't say, and that you are among the small number of people awake enough to see it. The voice uses words you have met in this very book: plasma, current sheet, geomagnetic storm, magnetic reversal, and uses several of them correctly. Nothing in your ordinary education has equipped you to know in that moment whether you are listening to a suppressed ALF fan or a confident stranger with a coffee-stained forecast. That moment, the honest bewilderment of an intelligent person who cannot personally rederive plasma physics at midnight, is the moment this whole book has been preparing you for, and this chapter is where I try to hand you the tools rather than the verdict. That same commitment to honesty requires this chapter to exist. Open-mindedness is not the same thing as a lack of standards, and a book that spent 8 chapters teaching you to hold ideas to a fair, evidence-based standard would be doing you a disservice if it didn't also show you what it looks like when someone borrows the language and imagery of this book's subject matter, plasma, solar activity, electromagnetic forces, without doing any of the actual work this book has tried to model. There is a real cost to failing to make this distinction, and it isn't abstract. People who come to trust a source because it sounds scientifically literate, uses real physics terms correctly in places, and positions itself as braver and more open-minded than the mainstream, can end up organizing real fear, real spending, and in some documented cases, real emergency preparations around predictions that have no more substance than a weather forecaster guessing at next month's rainfall from a coffee stain. This chapter is about that difference, and it uses one specific prominent example to make it concrete: Ben Davidson and the YouTube channel he founded, Suspicious0bservers. Let me be clear about what kind of chapter this is, because it is the only one of its kind in the book. Every earlier chapter took a minority claim and tried in good faith to argue for it, to show you the strongest version of a position the mainstream rejects. This chapter does something structurally different and, in a way, more important. It turns the same standard of judgment on a claim that fails it, so that the standard itself becomes visible. Think of it as the book's calibration weight. You cannot trust a scale that only ever reads in one direction. If I asked you to weigh the electric sun and the liquid metallic hydrogen sun and plasma cosmology, and could not show you a single case where I set the same instrument down and watched it read empty, you would be right to wonder whether my scale reads anything at all, or whether it simply tips toward whatever is unpopular. So this chapter is where the method proves it can say no, and in proving that, earns the right to have said yes elsewhere. Underneath the specific case study runs the real subject of this final part of the book: how a thoughtful person who is not a specialist can weigh a mainstream claim against a minority one and reach a defensible judgment of their own. That skill has moving parts, and I will try to name each of them as it comes up. The difference between a prediction and a postdiction, the meaning and the limits of falsifiability, the crucial and constantly confused distinction between a view that has been unfairly dismissed and a view that is simply quietly wrong, the difference between the genuine institutional inertia that has buried real discoveries and the crankery that dresses itself in inertia's clothing, and, at the end, the honest question every open mind should keep in its pocket. What would actually change my mind about this? Davidson is the working example. The tools are the point. Who Ben Davidson is? Ben Davidson holds a bachelor's degree in economics from Denison University and a Juris Doctorate from Capital University Law School. He has no formal training in physics, astrophysics, geology, or any of the scientific fields his content covers. In 2011, he and his wife Kat founded a YouTube channel called Suspicious0bservers, later rebranded as Space Weather News, delivering near-daily videos on solar activity, space weather, and their supposed effects on Earth. The channel has grown into a substantial media operation, encompassing multiple websites: suspicious0bservers.org, spaceweathernews.com, magneticreversal.org, and QuakeWatch. Net among them, along with published books, including one titled Weatherman's Guide to the Sun, paid tickets to an annual conference, membership tiers, and a large YouTube subscriber base numbering in the hundreds of thousands, with total views across the channel's history reported in the neighborhood of 200 million. It is worth pausing on the scale of that operation because it changes what is at stake. A wrong idea whispered in a faculty lounge harms almost no one. A wrong idea delivered daily with production values and a warm voice to an audience the size of a mid-sized nation's over more than a decade is a different kind of object. 200 million views is not a fringe, it is a broadcast network. And a broadcast network built on daily updates has a specific appetite. It must be fed every day, which means it must find something alarming or portentous in the sun every single day, whether or not the sun is actually doing anything unusual. Keep that structural fact in mind. It will matter enormously when we get to the difference between a claim that risks being wrong and a claim engineered never to be checkable at all. Let me be direct about why this chapter opens with his credentials. Given that this book has otherwise tried to avoid treating a person's formal training as the deciding factor in whether their ideas deserve consideration, Ralph Jurgens was a civil engineer, not an astrophysicist, and this book gave his ideas a full hearing anyway. The difference isn't that Davidson lacks a physics degree. It's that the rest of this book's featured researchers did real, specific technical work within their areas of expertise. Scott's circuit analysis background informed his transistor model of the corona. Robitaille's actual, hands-on laboratory experience with thermal emission and MRI hardware grounded his Kirchhoff's law argument, however far it ultimately reached. Davidson's content, by contrast, spans geology, seismology, climatology, and astrophysics simultaneously, with no comparable base of specific technical experience in any of them, a breadth of claimed expertise that is itself a common feature of pseudoscience, where a single figure confidently pronounces on an implausibly wide range of unrelated technical fields at once. Let me slow down here, because this is exactly the kind of argument that can be abused, and the history of science is littered with people who used it to bully outsiders who turned out to be right. Alfred Wegener, who proposed continental drift in 1912, was a meteorologist and balloonist, not a geologist. The geological establishment spent decades dismissing him partly on the grounds that a weatherman had no business rearranging their continents. He was right, and they were wrong, and the vindication came only in the 1960s, with seafloor spreading long after his death on the Greenland ice. Barbara McClintock's work on mobile genetic elements was ignored for years, partly because it came from a woman working somewhat outside the dominant framework of her field. She too was right, and the Nobel arrived in 1983. Michael Faraday, arguably the greatest experimentalist of the 19th century, had almost no formal mathematics, so the mere fact that someone is working outside their credentialed lane is not, by itself, evidence that they are wrong. It cannot be, or half the discoveries in this book's own argument would evaporate. The real distinction is subtler, and it is worth learning to see because it is one of the most reliable single tools you will ever carry. Wagner trespassed into geology, but he trespassed narrowly and deeply. He brought one specific body of evidence, the matching coastlines and fossils and rock strata across the Atlantic, and he pressed on that one problem for the rest of his life, defending it against the strongest objections geologists could raise. Philosophers have a name for the failure mode that looks like Wegener but isn't: epistemic trespassing, the habit of carrying the confidence you legitimately earned in one field into a dozen fields where you have earned nothing, and speaking in all of them with the same untroubled certainty. Wegener trespassed once, humbly, and stayed to do the work. The pattern this chapter is about is trespassing everywhere at once, quickly, and never staying anywhere long enough to be pinned down. The tell is not the border crossing. The tell is the breadth, the speed, and the refusal to remain in any one field long enough for its specialists to check the claim against what they actually know. There is also a simple, unglamorous reason genuine expertise tends to be narrow, and it is worth stating plainly because it is the physical basis of the whole diagnostic. Seismology, climatology, and stellar astrophysics are each the accumulated labor of thousands of careers. A single one of them takes a decade of full-time work to reach the frontier of, and even then a specialist will tell you they command a sliver of it. The claim that one person, without formal training in any of them, has simultaneously seen to the bottom of all three, and found that the entire assembled expertise of each is missing something obvious that he alone perceives, is not impossible. But it is a claim about the world that carries a very low prior probability, and fairness requires letting that prior do its quiet work before the first piece of evidence is even weighed. The claims, suspicious0bservers organizes its content around what the channel itself describes as 4 core claims, sometimes called its pillars, that the sun plays a significant causal role in triggering earthquakes on Earth, that measurements of electrical and magnetic activity in the atmosphere can be used to predict where and when earthquakes will strike, that mainstream climate science has substantially mischaracterized the causes of climate change, downplaying solar influence in favor of human activity, and that dark matter is not an exotic, undiscovered substance at all, but simply ordinary matter we cannot yet see, a stance that sits directly downstream of the electric universe concepts of the kind discussed earlier in this book. That last pillar, explicitly, is exactly why this chapter belongs in a book on electric universe cosmology rather than standing apart from it. Davidson's content sits downstream of exactly the same broad framework this book has spent 8 chapters examining, and readers drawn to this book's subject matter are, realistically, more likely than most to encounter his channel and need a clear basis for telling the two apart. Some of these claims are testable in a fairly direct way, and how that testing has gone is worth examining. The United States Geological Survey, the primary American scientific authority on earthquakes, has stated plainly that despite decades of dedicated investigation, no reliable mechanism links space weather phenomena like solar flares and geomagnetic storms to earthquake triggering, and that any apparent correlations researchers have investigated are best explained as statistical coincidence rather than causation. More specifically, the broader scientific literature on earthquake prediction via electromagnetic precursor signals has found that the kind of signals Davidson's model relies on are not reliably detected in the specific, short window immediately before an earthquake in the way a genuine predictive method would require. When unusual electromagnetic signals are observed near fault zones at all, they tend to appear over long, diffuse periods, not as a clean, actionable warning shortly before a specific specified quake. Compare this directly to the standard this book applied to the electric comet model's advanced predictions in Chapter 6. Thornhill's water ice and deep impact predictions were specific, dated, and checked publicly against a real, singular event. A serious earthquake prediction methodology would need to meet the same bar: specific location, specific magnitude, specific window, checked openly against outcomes, and the available public record does not show Davidson's methodology being held to or volunteering itself for that same standard of scrutiny. It helps to make the physics concrete, because the mainstream case here is not merely a bureaucratic denial, it is a statement about energy, and energy can be counted. An earthquake is the release of elastic strain that has been slowly loaded into rock by the motion of tectonic plates, which grind past one another at speeds of a few centimeters a year, roughly the rate your fingernails grow. Over decades and centuries, that creep stores an enormous reservoir of mechanical energy in the crust. A great magnitude 8 earthquake releases on the order of 100 quadrillion joules of it, comparable to a large thermonuclear weapon, in seconds. Now ask what a solar storm actually delivers to the rock? A geomagnetic storm couples energy into Earth's upper atmosphere and magnetosphere, and it can drive currents through the ground, the same geomagnetically induced currents that trip power grids, but those are currents of amperes flowing through the crust's thin conductive skin, depositing trivial amounts of heat and exerting mechanical stresses many orders of magnitude below what a locked fault has already stored and is waiting to release. The sun does not reach down and pull the trigger. The trigger has been under mounting internal pressure for a century, and the question of exactly when it slips is governed by the rock, not the sky. The scale of that mismatch is easiest to feel through a comparison the mainstream itself takes seriously. The solid body of the earth flexes measurably under the tides raised by the moon and sun. The ground beneath you rises and falls by a foot or so twice a day, and those tides impose stress changes on faults of a few thousand pascals, thousands of times larger than anything a geomagnetic storm can induce mechanically in the crust. And what do seismologists find when they look for the tides triggering earthquakes? Only a faint, statistically delicate influence on the timing of quakes already primed to fail. Detectable at all only in enormous data sets, and only for faults already at the very edge of rupture. If the tides, straining the whole planet twice daily, can manage only a whisper of influence, a solar storm's far smaller ground stresses cannot plausibly be the loud, specific trigger the earthquake pillar requires. This is what physicists mean when they say a mechanism is absent, not that no one has looked, but that the numbers, properly compared, do not leave room for the claimed effect. There is also a lesson here about the difference between finding a correlation and having a prediction, and it is one of the most important habits of mind this whole book is trying to build. The Earth is a seismically busy planet. Something like 1,500 earthquakes of magnitude 5 or greater occur every year, more than 100 of magnitude 6, roughly one every day somewhere of a size worth noticing. The Sun, meanwhile, throws off flares and coronal ejections on a similarly frequent irregular schedule. Given two busy calendars like that, you are guaranteed to be able to point, after the fact, at a solar event that preceded almost any earthquake you like within some window, a day, 3 days, a week, and call it a match. That is not prediction. It is postdiction, the retroactive pairing of two common events, and it will produce an impressive-looking string of hits no matter whether any causal link exists at all. The only cure is the one the careful models in this book submitted to: Name the location, the magnitude, and the window in advance in public, and then let the misses count as loudly as the hits. A method that is only ever scored on the quakes that happen to follow a flare, and never on the flares that were followed by nothing, is not being tested. It is being flattered. There is a sobering history behind all of this that the mainstream does not hide, and fairness requires putting it on the table. Scientists have wanted a real earthquake prediction method for a century, and some serious researchers have chased electromagnetic precursors in earnest, most famously the so-called Van method developed in Greece in the 1980s, which claimed to forecast quakes from telluric electrical signals in the ground and generated a long-heated technical controversy in the peer-reviewed literature. The reason that effort is remembered as a cautionary tale rather than a triumph is instructive. When the claimed successes were subjected to rigorous pre-registered statistical scrutiny, they did not clearly outperform chance, and the community, after arguing it out in the open in real journals, largely concluded the method had not been demonstrated. That is what the honest pursuit of a hard, seductive idea looks like. Public claims, public scrutiny, and a willingness to let the verdict go against you. The contrast with a channel that produces daily, unfalsifiable intimations of heightened risk is not that one had an exotic idea and the other didn't. It is that one put its neck on the scientific block and the other never did. On the climate question, Davidson's channel has argued that variations in solar output rather than human greenhouse gas emissions are the primary driver of recent climate change, a claim examined and rejected by climate scientists directly, who have found that measured solar output has not increased over the recent decades of most rapid warming, making it physically incapable of explaining that specific warming trend. However, real and worth studying solar variability is as one contributing factor among many over longer timescales. The science journalist Peter Hadfield, publishing as Potholer 54, has built much of his career around exactly this kind of claim-by-claim climate fact-checking, and his direct engagement with Davidson specifically targeted this pillar, walking through the actual satellite-measured solar irradiance data alongside Davidson's presentation of it. Here again, the mainstream case is quantitative, and the numbers are worth seeing rather than taking on trust, because they are the whole argument. The sun delivers about 1,161 watts per square meter to the top of the atmosphere, and satellites have measured this quantity, the total solar irradiance, continuously since the late 1970s. Across the 11-year solar cycle, it wobbles by only about 0.1%. Roughly 1 watt per square meter at the top of the atmosphere. Spread that over the whole rotating, partly reflective globe, and it amounts to a climate forcing of well under 1/4 watt per square meter, and it swings up and down with the cycle rather than trending in any one direction. Set that beside the forcing from the carbon dioxide humans have added since pre-industrial times, which is on the order of 2 watts per square meter and climbing steadily in one direction, roughly 10 times larger and unlike the solar cycle, not a wobble, but a ratchet. The decisive fact is the divergence. Since about 1980, the satellite record shows total solar irradiance essentially flat or slightly declining, while global temperatures have climbed markedly. Two lines going opposite directions cannot stand in the relationship of cause and effect the claim requires. This is not the mainstream refusing to consider the sun. It is the mainstream having considered the sun carefully, measured it, and found it cannot carry the weight assigned to it. None of that erases the real science of solar influence on climate, and an honest account has to hold both truths at once. Over longer stretches, the deep solar lull of the Maunder minimum in the 17th century, which coincided with the coldest phase of the Little Ice Age, solar variability plainly does nudge the climate. and researchers study it because it is real. The error in the pillar is not the claim that the sun matters. It is the specific, testable claim that solar output is the primary driver of the warming since 1980, a claim the direct measurements refute. Getting that distinction right is itself part of the discipline this book keeps asking for. A factor can be real, worth studying, and still be the wrong explanation for a particular effect. Perhaps the clearest illustration of the difference between this chapter's subject and the rest of this book involves the specific claim that Earth's weakening magnetic field could, by his account, cause mass casualties on the order of tens to hundreds of millions of deaths within the coming decades. A dramatic, specific, headline-generating prediction that a working solar physicist reviewing the claim directly on the YouTube channel Space Weather found to have no support in the actual physics of how Earth's magnetic field and cosmic ray exposure interact. Contrast this directly with how this book has tried to handle its own bold claims. When Chapter 6 examined the pre-Rosetta electric comet prediction, it reported plainly that the prediction failed its test. Nothing in suspicious0bservers' public output suggests a comparable willingness to revisit or retire a dramatic, failed prediction once directly challenged by someone with relevant expertise. The magnetic field claim rewards a careful look because it is a case where real physics, a weakening field, real geomagnetic excursions in the past, is stretched into a false conclusion, and learning to see exactly where the thread snaps is a transferable skill. It is true that Earth's magnetic field has weakened by several percent over the last century, and that its poles wander and, over geological time, reverse. A full reversal takes something like 1,000 to 10,000 years, and during it the field does not vanish but becomes weaker and more tangled. The claim's leap is from weaker field to mass casualties from cosmic rays, and that leap ignores the shield that actually protects you. The atmosphere over your head is the equivalent of about 10 meters of water in mass per square meter of ground, and it absorbs the overwhelming majority of the cosmic ray cascade. The magnetic field mainly deflects the lower energy particles and matters most near the equator, which is precisely why the field already does very little shielding over the poles. And yet no one is dying of cosmic rays in northern Canada. Your annual radiation dose from cosmic rays at sea level is a fraction of a millisievert, a small slice of your total natural background, and even a substantial increase leaves it far below anything acutely dangerous. The decisive piece of evidence, though, is that this experiment has already been run. Roughly 41,000 years ago, the field collapsed to a small fraction of its present strength during the Lachamp excursion, a real, well-dated event recorded as spikes of cosmic ray-produced beryllium and carbon isotopes in ice cores and sediments. Cosmic ray exposure did rise, and the human beings and Neanderthals alive at the time were not wiped out by radiation. The fossil and archaeological record shows no mass die-off attributable to it. When the mainstream says a weakening field will not kill tens to hundreds of millions of people, it is not offering a reassuring opinion. It is pointing at a natural experiment already performed on our own ancestors with a survivable result. This is the difference in its purest form. The alarming claim postdicts nothing and predicts a catastrophe the geological record has already declined to deliver. A practical checklist. Because this book's whole purpose has been to equip you to weigh evidence for yourself, rather than simply deliver verdicts, it's worth turning the Davidson case study into something more directly useful, a short, practical set of questions you can carry into any encounter with a claim that presents itself as bold, suppressed, minority science, whether it's about the sun, the earth, your health, or anything else. Before the individual questions, one master question stands over all of them, and it is worth holding in mind as you read the rest. Does this claim make itself vulnerable to being wrong? Everything below is really a way of asking that one thing from a different angle. A claim that has been arranged by vagueness or evasion or renewable alarm, never to be checkable, has already told you the most important thing about itself, whatever its subject and however fluent its vocabulary. Science is the practice of sticking your neck out. A claim engineered to keep its neck permanently out of reach is not doing that practice, no matter how much of its costume it borrows. Does the claim make a specific, dated prediction, or does it stay comfortably vague? Increased seismic risk in the coming period is not a prediction, it's a mood. A magnitude 6. 5 or greater earthquake within 400 miles of this location within the next 5 days is a prediction, and it's the kind this book asked every model in its earlier chapters to make and be judged by. The deeper principle underneath this question is the difference between a prediction and a post-diction. A prediction is made before the fact, names its target narrowly enough that most possible outcomes would refute it, and cannot be quietly adjusted after the result is in. A post-diction is the art of finding, after something happens, a story in which it was expected all along. And because there is always such a story available, post-diction is worthless as evidence no matter how satisfying it feels. When you catch a source only ever explaining yesterday's quake, and never staking out tomorrow's, you have caught it postulating, and you should mentally set its track record back to 0. When a specific prediction fails, does the source report the failure, or does it quietly move on to the next one? This book reported the electric comet model's failed water ice prediction in detail, in the same chapter that made the prediction's case. A source that only ever highlights its hits, never its misses, is not giving you the information you'd need to actually evaluate its track record, and the absence of visible misses is not itself evidence of a good track record. There is a subtle statistical trap hiding here that is worth naming. A source that makes many vague predictions and then loudly commemorates the handful that seem to come true while never counting the ones that didn't, will generate an endless stream of apparent successes purely by chance, the same way a stopped clock is triumphantly right twice a day if you only photograph it at the right moments. The only meaningful track record is one that counts the misses as carefully as the hits, and a source unwilling to show you its misses is, whether it knows it or not, hiding the only number that matters. Is the person's claimed expertise actually relevant to the specific claim being made? And is it a narrow, deep expertise or a broad, shallow one? For Robitaille's Kirchhoff's law argument came from decades inside one specific relevant technical field. A single source confidently covering seismology, climatology, orbital mechanics, and cosmology all at once, without deep specific grounding in any one of them, should raise your guard rather than lower it, regardless of how fluently the terminology is used. Remember the Wegener caveat, though, because this question is the one most easily abused. The point is not that an outsider must be wrong, since the outsiders in this very book were sometimes right. The point is the shape of the expertise. Genuine command is almost always narrow and deep, bought with a decade of one field. A confident, simultaneous mastery of many unrelated technical fields is a shape expertise almost never takes, and the broader the claimed range, the lower the prior it earns. How does the source respond when directly, technically challenged by someone with relevant expertise? Real counter-argument, even unpersuasive counter-argument, is a sign the person is still operating inside the norms of genuine inquiry. Personal attacks, threats, or dismissing the critique without engaging its substance are not. This is the checklist's single most reliable item, for the reason the whole response to criticism section laid out. The original claim tells you where someone started, but the response to a strong objection tells you what they are trying to do: find the truth or defend a position. Watch, specifically, For the person who answers a pinned objection by galloping to a fresh claim rather than conceding or defending the old one, and for the person who answers an argument with an accusation about the arguer. Both are ways of not engaging the substance, and both are worth weighing heavily wherever you meet them. Does the business model depend on the claims staying frightening? A researcher publishing in an obscure journal has very little to financially gain from you personally believing them. A source selling memberships, supplements, survival supplies, or conference tickets tied to an ongoing sense of imminent catastrophe has a direct structural financial interest in your continued fear, and that incentive is worth weighing carefully. The same way this book asked you to weigh any other source of potential bias throughout its earlier chapters. Notice that this is a question about structure, not about sincerity. The source may believe every word. The point is that a daily operation which must be fed daily and which is funded by an audience that keeps subscribing only as long as it keeps feeling afraid, sits inside an incentive that pulls steadily toward alarm and away from the boring nothing happened today that is, most days, the truth about the sun. Let me add one more question the Davidson case brings into focus, because it may be the most powerful of all. Does the claim require overturning many separate, independently established results at once, or does it fit alongside them? A true idea usually connects. It explains the thing in front of you and stays consistent with everything already well measured elsewhere. The earthquake pillar, taken seriously, would require the energy accounting of seismology to be wrong, and the tidal triggering studies, and the statistics of correlation, all at the same time and in a coordinated way. When a single claim demands that a dozen unrelated, well-tested bodies of knowledge all be broken in exactly the way needed to rescue it, the probability that reality is arranged so conveniently is very low. Not zero, but low enough that this should be near the front of your mind. Scientists call the opposite virtue consilience, the quiet strength of a claim that is independently supported from many directions at once, which is exactly what the dark matter case in Chapter 8 has, and the earthquake pillar conspicuously lacks. None of these questions on their own proves a claim false. Robitaille's model faces real, serious, unanswered problems, and I still gave it a full, respectful chapter because his expertise was genuine, his engagement with critics was substantive, and he had no comparable business model riding on the claim's continued truth. The checklist isn't a shortcut that replaces the work of actually examining the physics. It's a set of warning flags that should raise the bar of scrutiny a claim needs to clear, not a replacement for clearing it. Let me be especially careful about this, because a checklist is exactly the kind of tool that can curdle into the lazy dismissal this book was written against. Used well, these questions tell you how hard to look, not what you will find when you do. They are a way of allocating your scarce attention and your scarce trust, spending more of both where the flags are few and the claim is checkable, less where the flags crowd in, and they are never a substitute for the slow, specific work of weighing the actual evidence on the actual question. Eyes open, no fear, don't get caught in doomsday cults, online selling survival prep to pay for the farm.